Okay, right, so today we are carrying on with adding fractions. We just can't get enough of adding fractions. So we are doing mixed numbers today, so two mixed numbers. And obviously yesterday we did, for example, it was a mixed number and a proper fraction. But today we're going to be doing mixed number and mixed number. Something like this. So we're going to pick a slightly nicer one. So today's ones are going to be slightly simpler, and then we'll sort of like move on Monday to a slightly more challenging version of them. So today's ones are a bit friendlier because if I show you, your examples like this are going to have the denominators the same. And this will just make your life so much easier. So much easier today. So we won't worry about what we're going to do on Monday for now, but this is what we are doing today. So some of you will be able to look at this problem and will quite quickly in your heads be able to give me the answer. And that's brilliant. Not everyone's brains work like that, and that is fine. So I'm going to model to you how we would go about solving this if we were not able to do it in our head. So as you can see here, we have got two mixed numbers. And just like we did yesterday, we don't mind working with mixed numbers, but it makes our life a lot easier if we convert these into improper fractions. And if you remember from yesterday, an improper fraction is when you have the larger number on top, such as 20 over 4, such as 5 over 3. Any sort of example where the numerator, the top number, is larger than the denominator. So we're going to have a go at converting these first into improper fractions. So remembering from yesterday, and if you are still a bit unsure about this step, there are those videos or website links on our Home Learning Hub page for you. So step number 1, we're going to convert 2 2/5 into an improper fraction. So we have got our denominator here, which is 5. We're going to say to ourselves, well, what is 5 times 2? And I know that is 10. Just going to pop it up there. And then we add 10 and our numerator together, which gives me 12, which is 12 over, and that's going to be 5 because we always keep our denominators the same. Now, this is a perfect opportunity right now to do a little diagram. So I'm going to leave this here for a minute, but I'm just going to sort of compare both of these together, because if you remember yesterday, we talked about like showing these in picture form. And we like doing things in picture form because they really help us see it and like visualize it. So I'm drawing out here 3 little bars. Now I'm going to chop these up into different sections. Do you know what the sections would be? So it's going to be 5 because that's our denominator. That's how many parts we're splitting up our fraction into. Can I get this into 5s evenly? We will see. 1, 2, 3, 4. It's a little bit uneven. Okay, 1, 2, 3, 4, 5. Right, it's not terrible. Split these into 5s. There we go. Worst bit's done. Drawing bit's harder than the maths. So we've got a little 3 sections here. So I have got 2 whole bits, 2 whole sections. So I'm going to colour in like so. So this equals 1 and that equals 1. So that's 1 whole, that's 1 whole, and obviously both of these equal 2, like so. Now I've then got this section here. Now this is not all going to be coloured in because this is part of the whole. And as we can see up here, 2 is my numerator So it's 2 out of 5. So 2 out of 5 will be shaded. And this represents 2/5. 2 out of 5. So this diagram here represents 2 and 2/5. It also represents 12 over 5. Because if you look here, if we were to count up all the individual sections, that is the number we should end up with. So we can see we've got 5 here, 5 here. I know that 5 and 5 gives me 10, 11, 12. So 12 over 5. Okay. So again, if you need to draw diagrams like this out, absolutely fine to do. We encourage it. It really helps to visualize the problem and what you are looking to do. So we'll get rid of this for now. Doesn't mean you can't go back and watch this again if you think it's going to help you. Right, so now we're going to have a little look at this mixed number over here. So I'm going to do the exact same again here as I did for my first one. I'm going to say 5 times 1, well that's 5. Add the 4, and I have got 9. 9 over 5. So we've got 12/5 and 9/5, which obviously we are going to have to add together now. Now this is why we're doing this step today, partly because it's a Friday, it's been a long weird week, but also we'll just keep these the same for today so we don't have to worry about doing any further conversions. So 5 and 5, they're the same. My denominator can remain as 5. And then I just have to add my 2 numerators. So 12 plus 9. Well, I know 12 plus 8 is 20, so that's 21. Like so. And I've got 21 over 5. Excellent. But there is a rule which you might remember from yesterday. I really hope you do. I hope you're sat there now. I know what the rule is. When we have questions like this, where we have mixed numbers in the question, your answer must also be in mixed number form. So yes, this is correct, but I need to make this into a mixed number. So we're going backwards. So 5 is our denominator. 5 is it's a good number. We like 5. Write my multiples of 5 out because sometimes we need that. And if you ever need to do things like that, that is okay. So again, our division, it's like a division sum here. That's what the line represents. So we've got 21 and 5. How many lots of 5 can we get? How many whole lots of 5? Well, I know, looking over here, I can get 4 lots. 4 whole lots, because 4 times 5 is 20. But I've got something left over. I keep my denominator the same. I keep it as a 5. And again, we sort of ask ourselves over here, well, we know what's left over. It's like saying 21, take away 20. That leaves me with a 1. So I will be left with 4 and 1/5. Now, just like yesterday, we always like to check. We have the time to sit and check. Reverse like we did over here. Just going to double check. I know that 5 times 4 is 20 plus the 1 would give me 21 over 5. And I now know that I am correct. Something else to bear in mind, and I can talk about this on Monday with you when we sort of take this up a step. You always need to make sure that this bit of your fraction, so if I write it up here, you need to make sure that this bit here is always in its simplest form as well. But luckily, 1/5 is the simplest it can possibly be today, so we don't have to do anything further. Okay? Right. Good luck, everybody.